Hey students, we are going to talk about Chapter 2, Bioenergetics. I know that you have a lot of information posted. The actual textbook PowerPoint is posted for you in Moodle, but I also wanted to take this time to give you a little bit of a lecture and hit on some of those key points from Chapter 2 about bioenergetics. All this information, again, is taken from your textbook. So if you need a reference back to figures, you can look there. All right, so what is bioenergetics? Bioenergetics is the idea that we are going to take the food stuff that we eat and convert it into usable energy for our body. The only usable energy that our body can use to do work is adenosine triphosphate, ATP. ATP is our hero, it is our king, it is our queen. Any muscle action that is happening in our body is fueled by ATP. ATP is our hero, okay? So what do I mean by food stuff? Food stuff is the Pop Tart that you had for breakfast that contained basically just carbs and fat, because I don't think Pop Tarts have any protein in them. I'd have to double check on that. But let's just say carbs and fats. So the Pop Tart that you ate for breakfast this morning, your muscles can't just say, ooh, a carbohydrate. I'm going to use that to do energy. Or, ooh, fat molecules. I'm going to use those to do energy, to create some energy. The idea really is that we need to take those carbs, those fats, and those proteins that we eat, break them down into substrates so that we can then create ATP. As I said, our carbs, fats, and proteins get broken down into smaller substances or smaller molecules that our body will use in order to create that ATP. So our carbs are broken down into glucose and they are stored as glycogen. Our fats are broken down into free fatty acids. Sometimes you will just hear me refer to them as fatty acids and not free fatty acids. And then protein is broken down into amino acids, but it has to be converted back to glucose via gluconeogenesis. So we really have three main things, carbs, fats, and proteins that are broken down into glucose and fatty acids. Ideally, really the only two main substrates we are using are glucose and fatty acid. All right, so carbohydrates and fats, what are they doing for us? Carbohydrates are all converted to glucose. They are going to be stored as glycogen if we have extra in the liver and the muscles. Okay. Glucose is just floating around in our bloodstream. Okay. And we are reaching out trying to grab a glucose molecule in order to do work, right? Carbohydrates are worth about 4 calories per gram of carbohydrate. Fats are worth about 9.4 calories per gram. And then protein is also worth 4 grams. So when you look at a nutrition label, when you are grabbing something to eat and you check out that nutrition label, you can figure out how many calories per serving are in something just by knowing how many total grams of carbohydrates, protein, and fat is in the item. For example, we have 8 grams of fat, so 8 times 9 would be our 72. So 72 calories. Our carbs, 37 grams. We're going to multiply that by 4 calories per gram. So that equals 148. And then our protein, only 3 grams. 3 times 4 is going to be your 12. So if we took our 72, 148, and then 12 grams of carbohydrates, we get roughly 232 or our 230 calories. Okay, so fats are clearly the highest kilocalories per gram of substance that we eat. Okay, so carbohydrates, again, they're all converted to glucose. They're worth about 4 calories per gram. The primary ATP substrate for muscles and our brain is going to be carbohydrates. Extra glucose is going to be stored in as glycogen in both our liver and our muscles. Okay, fats. Fats are in a very efficient substrate. They have efficient storage. We know we had to break them down into fatty acids or free fatty acids. There is over 70,000 calories worth stored in our body, at least, right? We've got plenty of fat to go around. Energy substrate that is used for prolonged and less intense exercise. Okay, right now you are chilling, you are watching this video, hopefully staying awake, and you are like real low energy level, real low intensity level, right? Our heart rate's nice and low. Our body's basically just chilling in homeostasis, right? We are just chilling. So you are using predominantly fat to regulate your body right now to create that energy. It's mostly coming from fat, right? Fat and carbohydrates. We are just chilling at rest. We got 50% coming from carbs, 50% of our energy source coming from fat. Nice and chill. Fat will yield the highest amount of ATP produced, but it's slow. Okay? Carbohydrates are like, you need it, I can get it to you. I can get it to you quick. Fat is the turtle, right? It's slow and steady wins the race. Protein is our last resort to use for an energy source. Okay, what do we want protein to be stored at, saved for? We want protein to be saved for muscle increases, right? That's what really matters. And maybe not even muscle increases, just to sustain our muscle mass. Okay, protein is important for muscle maintenance and muscle growth. Okay, so protein, we don't want to be using protein as an energy source to help fuel our exercise, right? Protein, we don't want that. We want our protein to help build up and restore our muscles after we break them down through lifting or through exercise. So all of these kind of long term, when we think of these diets that are happening that are like zero carbohydrates, really, I have zero carbs right now. I'm on Atkins, I'm on keto, I'm on all these things that are no carbs. Carbs are our enemy. No, carbs are not our enemy. Carbs are our friend, because the majority of work that you do, that your body does, will come from carbohydrates. We need carbs to fuel our body and to create ATP in order for our muscles to be able to do work. As I said earlier, resting when we are just chilling, 50% of our energy stores are coming, or our energy is coming from a carbohydrate energy source, and 50% is coming from fat. When we have short exercise, so I'm going to say less than 3 minutes here, majority of it is coming from carbohydrates. And then when we have long exercise, we're using both carbohydrates and fat for that. There are 3 main energy pathways. Okay, we talk about 3 in this class. Sometimes I teach it broken up into 4, but we'll keep it with 3. Number 1 is the ATP-PC system. That is anaerobic metabolism. AN, anaerobic. Use that N to remember, N means no oxygen. There is no oxygen present when we are using our ATP PC system. Okay, that means it is quick, it is fast, there is no oxygen present. It is anaerobic. Okay. Next, we'll talk about our glycolytic system. That's where glycolysis happens. Sometimes you may hear me refer to that also as anaerobic metabolism. Okay, just in general. And then oxidative system, we have oxidative phosphorylation. Oxidative system is the only system that we will teach you in this course that is using aerobic metabolism. Okay, so that means oxygen is present. We need oxygen to break down and use. Oxygen is present in the pathways, in the energy sources, in order to create that energy to do work. Okay, anaerobic versus aerobic. We just talked about that. Aerobic means oxygen is present. Anaerobic, remember that N means no oxygen present.